So I'm going to share my screen now so that we can get started. Okay. So today we're going to be looking at data structures and algorithms. Data structures and algorithms. Now, if you want to get a job in a big tech company like Google, Facebook, Uber, Microsoft, X, all of them, you're going to be writing what we call data structures and algorithm problems. So data structure simply stands for a way of organizing and storing your data in memory so it can be used efficiently, whereas algorithm stands for the steps that are used in solving a problem. So in order for you to have a very good and efficient algorithm, you need a very good data structure to store them. And once you hear data structure, what you simply should come to your mind should be arrays, dictionary that we've looked at, arrays, dictionary, queue, stack, list. There's also trees and graphs. So those are data structures. They are simply memory spaces where you store your variables, your data, so that you can use algorithm to manipulate them. So your choice of data structure is very, very important. If you choose a very good data structure, then your algorithm becomes very efficient. And that is why we're going to be looking at some data structures and also some simple algorithms. Okay. Now, let's look at some data in real life, and then we'll see the kind of data structure that we use in storing them. So let's say you want to collect the students' names and you want to write them on a paper. The best data structure for that will be array, because you can simply say string array of name students equal to, you can put in the arrays like Augustine, Amos, Lois, IT, all of them in a single array of, because the data type, all of them are strings. Okay, now if you're looking at students that are in queue, let's say you want to go and collect something, you want to go and collect food, you're in the refectory and you want to collect food and students are queuing up, or you want to meet your form master for advice and all the students are queuing up, what kind of data structure do you think that would be? We'll call it queue, just like the way you normally call queue. When you go to bank, you have a queue. The first person stands in front and is being attended to first. That is a queue. So the first person that comes in is attended to first and he goes out first. That is queue. So for you to collect series of data that are expected, that the first data is going to be treated first before the next one, you put such data in a queue. Now, what is a stack? A stack is a situation where you have something like a stack of book. So let's say the data you're collecting, you keep one on the floor, you put the other one on top, put the other one on top. That is a stack, because the last one that you put on top, that's the one that will be attended to. Then you take it out before you start attending to the next one. That is stack. So a pile of books represents a stack. Now the fourth one is the dictionary, which we've looked at, like when you want to collect names of people together with their registration number. So you have a key value pair where the key is registration number, the value is the name. That is dictionary. So these four data types, they are basic, but they are very powerful. You're going to find out that most of the things you'll be doing in C# basic, you're going to be using them. Okay. Now, why data structures matter? Why is it so important that we are learning data structures? We are learning data structures because without data structures, your codes become very slow. If you don't pick the right data structure, if say you want to collect the data of people's name and you, instead of using array, you went and picked or stack or queue, you're going to be having slower code. Then your data become messy and the app don't scale. So you need to know the right data structure for a specific kind of data arrangement that you want to manage. So that is very, very important. Now, but with data structure, you're going to have faster programs once you choose the right data structure. Once you have a key value pair and you leave dictionary and go and use array, you're going to have a messy, slow code. But if you pick the right data structure, you're going to have a faster programs. Your codes are going to be cleaner, and you're going to have a better problem solving. So your algorithms are going to become very, very efficient. Okay, so that is introduction to data structures. Like I said, there are more other data structures that we're going to be encountering as we move forward. Now let's go into these data structures that we've just uh, looked at. We're going to be writing them in code and seeing how they are. Now, what is an array? We've already looked at an array. We say that array is a collection of values of the same type. The data type must be the same. If you look at this course, all of them are integers. That's why you have int here. And this square bracket represents array. So the data types must be the same. So this is a typical array. And arrays have fixed size, and they are very, very easy, fast to access. So they have fixed size. If you want to use an array but you don't want the array to have a fixed size, you use what we call list. List is very similar to array. You call it dynamic array, but we're going to be using it very soon. Now, how do you access an array? Simply put the name of the array and put the square brackets and the index that you want to access. So the first one is always having the index of 0, the next one 1, the other one 2, the other one 3. So it starts from 0. So arrays are 0 based index, they start from 0. Now we look at the second type of data structure, which is called the dynamic array. So dynamic arrays are lists, like I said before. So once you want an array that is dynamic, that does not have fixed size, then what you need to use is the list. And unlike this one that you wanted to add elements, you just write in the elements in the curly bracket. For this one, if you want to add the elements, you have to use the keyword add. That's the add method. So for the list, the sizes can grow. Unlike the array that has fixed size, this one, the sizes can grow, and it's most commonly used because most people want their size to grow, so they will be using this mostly. Okay, so let's go to the editor and start typing in some codes. Okay, so this is our editor, and now we're going to create a new console application that we can use for this practice. So who can tell me how to create a console application from what we've done so far, so that we can start this immediately? Can anybody help me create a console application? What command should I give? Yeah, you can unmute yourself and speak if you want to. Okay. I think IT wanted to talk, but maybe he's having problem with his computer. Is gonna come back. Okay. Does any other person want to help us with how to create a console application in C Sharp? Okay. So while IT is back, I think I can just do this. So to create a new application, you simply come to your terminal and make sure that you are in the C Sharp React course folder. then simply light.net, new, and we want to create a console application, and we'll give it a name by saying -n, and the name that we're going to be giving this is data structures and algorithms. Data structures and algorithms. Okay. Data structures and algorithms. Okay. So I'm going to press the enter key and let this application be created. Okay. So we can see now that we have this application created now. So the next thing we're gonna do will be to start writing our codes. Okay. So now I'm gonna go to the application data structures and algorithm, go to program.cs, which is where we'll be writing our codes. And I'm gonna make sure that I have my editor in the normal put to visual disable so that I can have my typing seen. Then I'm gonna delete this. So in this program.cs, that's where we start writing the codes. Okay. So the four data structures that we said we are going to be looking at today includes the array. Um, so let's start out immediately. So I'm going to come here and put this and talk about the array first. I will say that arrays are collection of values of the same type. So collection of values of the same type. That's what arrays are. Now, having noted what an array is, a typical example would be array of numbers. So in order to write an array, first thing, you have to indicate the data type of the values. So we are talking about integers. And we need to say that this is an array by making sure that we put in the square brackets. It has to be the square brackets. So once after that, we'll write the name of the array. So I'm going to call my own scores. Then after that, I'm going to use curly brackets to put in the values. So the value I'm going to be having here is I'm going to have 70. I'm going to have 85. I'm going to have 90. I'm going to have 60. So this is a typical array. So I'm going to close this out with a semicolon. So this is an integer array, and it's always good when you give an example of an integer array, also give an example of a string array. So I'm going to put the data type string, then say for names, okay? Then I'm going to have this as the string array. Now the next thing we're going to be looking at, and we'll say that arrays have fixed size. So once we've defined it with this size, that is always going to be the size. So let's look at list. So a list is a collection of values of the same type, just like an array, but the size can grow. So it's more of a dynamic array. So here the size can grow. So you can always grow the size. Then typical example of a list. How do you create a list? To create a list, you use the keyword list. You must mention the keyword list. Then in angle brackets, you indicate the data type of the list. So I'm gonna say I'm having a list that is a string. Then once I've said that, I can now have say fruits or names. Let me still use names. So for that, I'm now gonna say new list. So this is how you create a list, new list. Then I'm gonna repeat this angle bracket and still have my string data type inside it. Then normal brackets, then semicolon. So this is how you define a list. So you can define the list, then later you add in the contents of the list. So I'm gonna add in the contents. I'm gonna simply say names dot add. So I'm adding the name John. Then I'm gonna also have name dot add Jane. So with this, I have two names added to this list. So list is just similar to this array. It's only that you can always continue to add more elements. It can grow. Now we're going to look at another data type known as the stack. So we looked at, during my explanation, I explained the stack and the queue. So the queue is first in, first out. Like if you're queuing to, you go to the bank, you're queuing to use the ATM, you find out that the first person that comes and stands first, that's the first person. And it's also that first person that will be treated first. That's the first person that will use the ATM first and leave. So once you have that kind of arrangement, you have your data in a straight form like that, with the first person being treated first, we call such an arrangement a queue. But if you rather have something like a pile of book, like I said, everything in the world is referred to as data. So people queuing up is data. Pile of books piling up on your decks is also data. So you can arrange data in form of people queuing up or in form of books piling up on the decks. So for the books that are piling up on the decks, the first one you pull stays on the floor. But the next ones or the last one, that's the one that stays on top. And if you want to treat such data, you're going to treat that one on top first and remove it before the one on the floor. So the last one that came in, which is the last book, that's the one that will be treated first. And that's why we call the queue. Um, that's what we call the stack, last in, first out. So the queue is first in, first out, because the first person that stands in the queue, that's the first person that will be treated. Whereas the stack is last in, first out. Okay, so that is very, very important that we understand that. So we can simply say that what is a stack? So stack is also a collection, just collection of values of the same type, just similar to that of an array, but then the last one that goes in must be the first to go out. So that is very, very important. That is how you can differentiate a stack from an array. So all of them are linear representation of arrays of data of the same data type. But then how data goes in and go out, that's what differentiates them. Okay. So for you to define a stack, you simply say stack, then in angle brackets, stack, then in angle brackets, I think my editor is messing up, so I'm gonna just use IntelliSense for this. Good. So once you mention the stack, then you mention the data type, just similar to the list. Then put the stack's name. You can also use names for that. Then the new keyword with stack, and then the data type. Then after that, you can start adding things. So similar to the list, if you want to, instead of using add for this one, if you want to add for a stack, you're going to use the keyword push. So you can say names.push, you push in John, then name.push, you push in James. Okay. Now, if you want to take out something from the stack, you can use what we call pop. So I can try out and say console dot write line, and I do names dot pop so that I can pop out the last one. So once you pop out, what you're gonna see is Jane, because Jane is the last one that was put in, and that is gonna be the first one to go out. And that's because it is a stack. Now, the next data type we're gonna be looking at is the queue. And the queue is first in, first out. So you can see it's also a collection of data of the same type, similar to an array, but then how do you get something in and out? The first one that goes in is the first that goes out for a queue. So to define a queue is still the same thing. You simply write queue, then the data type, which is string, then the name of the queue, which we are using as names for now with the new keyword, and then queue, then the data type. Then you close out everything with the bracket and semicolon. Now, if you want to add something to the queue, you have to use the word enqueue. So queue, the queue name is names.enqueue. You can enqueue John. Okay. Then you can also enqueue Jane. But then when you try to dequeue, the first one that you dequeue is gonna be John, because the first in, first out. Okay. So if I write console.dequeue, I'm gonna have uh, John come out, because that is the one I'm dequeuing first. And the last data type that we're going to be looking at is the dictionary, which is a collection of key value pair. We've looked at dictionary already yesterday, so it's not something that is foreign for us. To define a dictionary, simply use the keyword dictionary, then the data types of the key and the value, then the name of the dictionary scores, then it's equal to new dictionary, then inside angle brackets you also have the data types of the key and values, then dictionary in our last class. Okay, so you can use dictionary for fast lookups, and you also use them in most of the apps that you're going to be building. You're going to find out that you'll be using dictionary for that. Okay, so those are the important data structures that we're going to be looking at now. In subsequent classes, we are going to be looking at more difficult ones, and also how to manipulate these uh, data structures. But for today's class, we are going to be looking at, we are more interested in honing down the definition of data structures and algorithm. So you can see from what I've just explained that these are just how you arrange your data. So you see, we are just arranging the same thing, names and the scores, names and scores, but you can see that they can be arranged in different ways, and depending on how you want to access them, how you want to take out the elements and put in more elements, that is what differs in them. And that is also very important in manipulating your data. It is good that you know how to the right one to choose. So depending on the kind of program, if you're writing a program of people going to, you want to automate how people go to bank and withdraw money, then you know that in banks they always stand in a queue, so you're going to be using a queue data structure for that. But if you want to automate how somebody keeps books on the table and takes them to use them to do something, you know you're going to be talking about stack. But if you're not interested in which one that goes in and goes out, then you're talking about array. And if you want the number of the elements to increase over time, then you'll be talking about using a list. So the data structure that you use depends on what you want to achieve. So whatever you want to achieve, that is what determines the data structure that you're going to be using. Okay. So that's said. So those are the things that are on this slide. So now we're going to be looking at algorithms. So what are algorithms? So algorithms, like I said before, are the step-by-step way of solving a problem. So how do you approach solving your problem? That is what algorithm is. So let's say, let's give a given instance of it. Let's give a very simple instance of a problem. You want to make a tea. How do you make a tea? If you want computer to automate making a tea, you want a robot to start making the tea, you have to write a program that will be installed in the head of the robot. And that program, for the robot to be able to execute making a tea for you, to help you make a tea in the house, the robot has to understand the step by step, what and what do you do after you do this one in order to have a tea. So you should be able to write a program that you install in the head of the robot that says boil water, because water has to be boiled first. Then after boiling water, you have to then add the tea. After adding the tea, you have to add sugar. Then you stir. That's how you get a tea. And you're going to find out that actually all these steps have also some uh, minute steps inside them, like to boil water. How do you boil your water? You need to get a kettle first. Then you need to put water inside the kettle. Then you can put it on your gas cooker in order for it to, then you turn it on, then you get the boiled water. So you can have steps inside these other steps. So these steps that you take in trying to solve a problem, that is what we call algorithms. So algorithms are the step-by-step way of solving a problem. And that is why you remember when we are looking at all those ATM code grading program, you see that I planned them out first. Then after planning, we design before we start developing. So in that planning, what I actually write there is the step-by-step way of solving that problem.